Hello everyone, this question is from partial differential equation asked in GATE 2023. So it was a Cauchy problem. So it is a first order PD. Okay, x del u del x plus y del u del y is equal to u, and they are giving an initial data curve like gamma here. Gamma is equal to t comma t, and your u is ft. Okay, now they are giving to ft. So in statement p they are giving this ft equal to 2t plus 1, and in statement q they are giving a different ft. Now they are asking that in the neighborhood of that initial data curve there exists a unique solution or infinite solution for this 2ft. Okay, so we have to verify statement p and q. These are the options. Okay, now to verify this statement, first we have to know about something, the existence uniqueness solution. Okay, for this Cauchy problem. So look, if your Cauchy problem is this, that there exists, if they are given a first order PDE like this, p del u del x plus q del u del y is equal to r function of xy u. This p is also a function of xy u, q is a function of xy u. Now if your initial curve is this gamma and passing through the point x naught, y naught, u naught, okay, and they are the function of t. Okay, now if this determinant, okay, the determinant looks like this, so it is your x0, it is your y0, and it is your u0, all are the function of t. So the derivative of x0 with respect to t, this is your x0. Derivative of y0 with respect to t, this is your y0. Okay, and here is your p. So this was your p del u del x plus q del u del y is equal to r, right? So we don't need this pqr, we need the p0. That means this p on that initial data curve. Okay, p at the point x naught, y naught, u naught. Okay, so we will name it as p0, and this is your q0. Okay, q at the point x0, y0, u0. So if this determinant, that derivative of x0, derivative of y0, and this p0 and q0, if this determinant is non-zero, then we will say that in that neighborhood of that initial data curve there exists unique solution. Okay, so if the determinant is zero, then we will not make a comment here. Now if the determinant is 0, then we will check that if this determinant is 0, then these two are equal, right? That p0 by x0 dash, q0 by derivative of y0, and here it is r0. R0 means r at the point x naught, y naught, u naught. This r0 by derivative of u0. If these three are equal, then you will say that there exists infinite solution. Okay, but if the case is not this, that means if the p0 by derivative of x0, this q0 by derivative of y0 is not equal to r0 by derivative of u0, then we will say that there exists no solution. Okay, so in our problem, let's make it now. So this is your PD, first order PD. They are given x del u del x plus y del u del y is equal to u. So if you compare this with this equation, p del u del x plus q del u del y is equal to r, then your p is x, q is y, and r is u, right? So this is your px. So your px yz, pxyu is x, qxyu is y, and r xyu is u. Okay, so this is your pqr. Now actually you have to you need p0, q0, r0 also, right? So from this p you have to know the p0, q0, and r0. But your x0 is what? Your x0 is giving, they are giving the initial data curve like this, t comma t comma u, right? So your x equal to x0, and that x0 is your t, and your y is also t, and your u0 is what? F of t, right? So they have given this initial data curve. Now if this is your x0, y0, u0, then what will be your p0, q0, and r0? Your p0 will be, your p is given at x, so p x y z is x, then your p x0, y0, u0 is what? It will be x0, and this x0 is given as t, right? So your p0 will be t. Similarly your q0 will be t, and your r0 you will be u0, and this u0 is f of t, right? So your r is f of t. Now on that, so everything is in your hand. Now you have to just check by this formula. Okay, so now first check the determinant first. So if you check this determinant, you will get what? This is your derivative of x0, right? So this is your x0 is t, y0 is t. So derivative will be what? Derivative of t with respect to t is 1. Second, this derivative with respect to t will be again 1. Okay, so this is a derivative of x0, this is derivative of y0. Here is your p0 and here is your q0. So your p0 is x0 and your q0 is y0. But what is the value of x0? The value of x0 is t, right? And here it is t, and value of y0 is t. So now you have this determinant, you are getting this determinant 1 1 tt. And what is the value of this determinant? It is 0, right? So I have already said you that if the determinant is 0, then you can't pass a comment. Okay, so the determinant is 0. From there I can't say that this option they are saying that there exists unique solution, this is not valid. From there I can't say that. Okay, so then what will I do? I will check by these two. Now rest of the things we will first check, and if it is also not hold, then also we can't say. Okay, now let's check the option q first, and then we will come to option p. Okay, so for q they are giving the f of t like this 2t minus 1. Okay, so if your f of t is 2t minus 1 and is so your initial data curve is what, x0 y0 and u0. Now they are giving this u0 is 2t minus 1 and your x0 is t and y0 is t. So if you check this determinant first, you will get this determinant, same determinant you will get. So if your determinant will be 0, okay, that means you have to check the rest of the things, that for infinite solution you will check this, right? These three are equal or not. So let's check this. So you have to check that p0 by derivative of x0, q0 by derivative of y0 equal to r0 by derivative of y0 or not. These three are equal or not. Okay, so let's check this. So p0 is what? Your p is x, right? Px yz is x. So p0 is x0, q0 is y0, and your r0 they have given u0, right? And what is your x0? X0 is t, your y0 is t, and your u0 is what? Now your u0, in the question they have said that u is ft, right? So now in the option q they are saying f of t is 2t minus 1. Okay, so your r0 is now what? That means your r is u, right? So r0 will be what? F of t, and f of t is 2t minus 1. So your r0 is now 2t minus 1. Now is this 3 equal, that t by 1 is equal to t by 1? These are good. But is it equal that t is equal to 2t minus 1 by 2? No, it is not equal, right? So that means it is holding the third one, right? So third one is what saying, if these three are not equal, then you say that there does not exist any solution. So no solution. Okay, so if there is no solution, that means what? They are saying that there exists infinitely many solution. This option is wrong actually. Similarly, from there you can check the option p. If you check the option p, in the option p there ft is what? 2t plus 1, right? So if you check here 2t plus 1, if you give here 2t plus 1, then also your u0 will be what? 2t plus 1, right? So then also these three are not equal. That means for option p, if f of t is this one 2t plus 1, then also there does not exist any solution. So if there does not exist any solution, then there will not exist a unique solution also. That means there is no solution even. Okay, so that means your option p is also wrong. So if both are wrong, then which option will be correct? Option D is your correct option. Okay, thanks. If you like the content, please make a subscribe.